In this video, I will be going over the section 10.3 Day 1 notes. And section 10.3, which is the last section in chapter 10, is going to cover geometric sequences. This is a sequence in which the ratio between successive terms is a constant. And that is going to be called the common ratio and is going to be denoted with the letter R. So in arithmetic sequences, they would either add or subtract the same number each time. Here they are going to multiply or divide by the same number every single time. So let's talk about that. For problem 1, 2, and 3, it says determine the common ratio and find the specified terms of each geometric sequence. So to find the common ratio, you are going to take, for example, the second term divided by the first term, or you could even take the third term and divide it by the second term. But you're going to set it up as a ratio or a division problem. So if I use the second term and divide it by the first term, you can see that my common ratio is negative 1/4. So what's happening is they are taking this number and they are multiplying by negative 1/4. And then they're going to multiply by negative 1/4 again. So if I wanted to find the next three terms, I would take 1/2 times negative 1/4, which is going to be negative 1/8. Okay, so let me write that out. So 1/2 times negative 1/4, which is negative 1/8. Then I would take negative 1/8 and multiply it by negative 1/4, which is going to be 1 over 32. And then I would take 1 over 32 and multiply it by negative 1/4 again, which would give me negative 1 over 128. But I'm multiplying by the same term every single time, and that multiplication is called the common ratio, and I denote that with the R. So number 2 says find the common ratio in the next three terms. So once again, I'm going to take the second term, so 2w plus 6, and I'm going to divide it by the first term. There's some factoring I could do here, but if you notice, once you take out a GCF, you can cancel the w plus 3's, and your ratio is 2. Now you can find that 2 maybe just by looking at the terms, but this is the way that you can find out for sure. So they're just multiplying by 2 every time, so then this would become 8w plus 24. Then I would get 16w plus 48, and then I would get, just multiply by 2 again, 32w plus 96. So they're multiplying by 2, a little bit easier to see, unlike maybe the last problem that was a fraction. All right, and number 3 says find the first three terms, and then find the common ratio. So a sub 1, a sub 2, and a sub 3 would be 4 to the first, 4 to the second, and 4 to the third, 64. All right, so the question is, what are they multiplying by each time? Well, if you can't tell just by looking at those numbers, you could take the second term and divide it by the first term. So it looks like their common ratio is 4. They're multiplying by 4 every time. And so we can have some formulas that will help us with these geometric sequences, very similar to arithmetic sequences, in the fact that things are going to run the exact same way for all of these sequences because they all will have a common ratio. So the formula to find any term is a sub n is equal to a sub 1 times r to the n minus 1 power. R is the common ratio, and a sub 1 is the first term. So let's go to the back and let's do some problems using this formula. All right, so for problem number 4, it says find the 17th term. So a sub 17 is equal to the first term, 1, times the ratio. I'll find that in a second, but I would raise that to the 16th power because it's 17 minus 1. So what are they multiplying by every time? Looks like they're just multiplying by 2. So 2 to the 16th times 1, 65,400. 536. For problem number 5, I want to find the ninth term, so a sub 9 is equal to the first term times the ratio raised to the 8th power. So if you can't tell what they are multiplying by, to find the ratio, you would take 2/3 and you would divide it by 2. And so 2/3 divided by 2 is the same thing as 2/3 times a half. So it looks like they are multiplying by a third. So you will take 1/3 to the 8th power, which is 1 over 6,561. And then when you multiply that by 2, that's 2 over 6,561. I want to keep it as a fraction because they have some fractions here. But the next one's going to use decimals. So the 27th term would be the first term, 189, times the common ratio, which I'll get in a second, raised to the 26th power. So to find the ratio, I will take 151.2 and divide it by 189. 151.2 divided by 189 is 0.8. So that's going to go here. And you would type this into your calculator, and I'm going to round it 0.571. So very similar to arithmetic problems. It's just a different formula that we're going to use here because we're multiplying or dividing instead of adding or subtracting. So in problem number 7, it says find both an explicit and a recursive formula. So I'm going to start with the explicit. I'm going to use our formula here. And so we have a sub n is equal to 8 times something raised to the n minus 1 power. And that's really all I'm going to be able to do here once I fill in the ratio. So the ratio is -2 over 8. So that's -1/4. I cannot take 8 times -1/4 because the -1/4 has a power on it. So you cannot combine any further. So these aren't going to be as difficult as what we saw with arithmetic sequences because there's nothing to combine here. So that's the explicit formula. The recursive formula would be the first term is 8. The nth term is going to be -1/4 times the term before it. And that's recursive. All right. Number 8 here, we have a sub n is equal to 2 times something to the n minus 1 power. The ratio would be 25 over 2, so that's 12.5. So that's explicit. And then the recursive would be a sub 1 is equal to 2, and then a sub n is equal to 12.25 times the previous term. And that is your video for today.